Section 10.2 Shapes of Molecules and Ions, VSEPR Theory. The three-dimensional shape of a molecule or a polyatomic ion is determined by drawing an electron dot formula and identifying the number of electron groups, one or more electron pairs, around the central atom. We count lone pairs of electrons, single, double, or triple bonds, as one electron group. In the valence shell electron pair repulsion theory, or VSEPR theory, the electron groups are arranged as far apart as possible around a central atom to minimize the repulsion between their negative charges. Once we have counted the number of electron groups surrounding the central atom, we can determine its specific shape from the number of atoms bonded to the central atom. Central atoms with two electron groups. In the electron formula of carbon dioxide, there are two electron groups, two double bonds, attached to the central atom. According to the VSEPR theory, minimal repulsion occurs when two electron groups are on opposite sides of the central carbon atom. This gives carbon dioxide molecule a linear electron group geometry and a linear shape with an bond angle of 180 degrees. Central atoms with three electron groups. In the electron dot theory of formaldehyde, C2H-O, the central atom C is attached to two hydrogen atoms by a single bond and to the oxygen atom by a double bond. Minimal repulsion occurs when the three electron groups are as far apart as possible around the central carbon atom, which gives 120 degree bond angles. This type of electron group drawing geometry is triagonal planar and gives a shape for H2CO called triagonal planar. In the electron dot formula for sulfur dioxide, there are also three electron groups around the central atom, a single bond to the oxygen and a double bond to the other oxygen and a lone pair of electrons. As in C2H-O, these three electron groups have minimal repulsion when they are in a triagonal planar electron group geometry. However, in SO2, one of the electron groups is a lone pair of electrons. Therefore, the shape of the SO2 molecule is determined by the two oxygen atoms bonded to the central sulfur atoms, which gives the SO2 molecule a bent shape with a bond angle of 120 degrees. When there are one or more lone pairs in the central atom, the shape has a different name than that of its electron group geometry. Central atoms with four electron groups. In a molecule of methane, CH4, the central carbon atom is bonded to four hydrogen atoms. From the electron dot formula, you may think that CH4 is planar with 90 degree bond angles. However, the best geometry for minimum repulsion is tetrahedral, which places the four electron groups at the corners of a tetrahedron, given bond angles of 109. When there are four atoms attached to four electron groups, the shape of the molecule or polyatomic ion is tetrahedral. A way to represent the three-dimensional structure of methane is to use the wedge dash notation. In this representation, the two bonds connecting carbon to hydrogen by solid lines are in the plane of the paper. The wedge represents the carbon to hydrogen oxygen bond of the page towards us, whereas the dash represents the carbon to hydrogen bond going into the page away from us. Now we can look at molecules that have four electron groups, of which one or more is a lone pair of electrons. Then the central atom is attached to one or two or three atoms. For example, in the electron dot formula of ammonia, NH3, four electron groups have a tetrahedral electron group geometry. However, in NH3, one of the electron groups is a lone pair of electrons. Therefore, the shape of ammonia is determined by the three hydrogen atoms bonded to the central nitrogen atom. The shape of the ammonia molecule is triagonal pyramidal with a bond angle of 109. The wedge dash notation can also represent this three-dimensional structure of ammonia with a nitrogen-hydrogen bond in one plane and one nitrogen-hydrogen bond coming towards us and one nitrogen-hydrogen bond going away from us. In the electron dot formula of water, H2O, there are also 4 electron groups which have minimal repulsion when the electron group geometry is tetrahedral. However, in the H2O, 2 of the electron groups are lone pairs of electrons. Because the shape of H2O is determined by the 2 hydrogen atoms bonded to the central oxygen atom, the H2O molecule has a bent shape with a bond angle of 109. Table 10.3 gives you the molecular shapes for the molecular with 2, 3, and 4 bonded atoms. Molecular shapes for a central atom with 2, 3, and 4 bonded atoms. 2 electron groups, the electron group geometry is linear. 3 electron groups is triagonal planar. 3 electron groups with 1 being lone pair and it's triagonal, it's a bent. 4 electron groups and you have a tetrahedral. 4 electron groups, 1 being a lone pair, and you have a triagonal pyramidal. And 4 electron groups with 2 lone pairs, and you have a bent molecule.